N-type semiconductors. N-type semiconductors are semiconductors which are obtained by adding pentavalent atoms to the pure semiconductors. Dear students, in N-type semiconductors, electrons are the majority charge carriers. So in N-type semiconductors, there is a generation of free electrons which are free to move. So these pentavalent atoms which can be added to the pure semiconductors such as silicon are atoms from the group 5 of the periodic table. Examples of pentavalent atoms are phosphorus, antimony, or arsenic. Phosphorus has 15 electrons. Electronic configuration of phosphorus is 2, 8, 5. Phosphorus has 1, 2, 3, 4, 5 electrons in its outermost shell. So phosphorus can lose 5 electrons or gain 3 electrons so as to become stable. The electronic configuration of arsenic is 2, 8, 18, 5. Arsenic has 1, 2, 3, 4, 5 electrons in its outermost shell. So arsenic can lose 5 electrons so as to become stable. Arsenic has 33 electrons. So the first shell occupies 2 electrons. The second shell occupies 8 electrons. The third shell occupies 18 electrons. Then the outermost shell of arsenic occupies 5 electrons. Antimony has 51 electrons. The electronic configuration of antimony is 2, 8, 18, 18, 5. Antimony has 1, 2, 3, 4, 5 electrons in its outermost shell. So antimony can lose 5 electrons so as to become stable. Pure semiconductors such as silicon have 4 valence electrons which undergo covalent bond with 4 electrons of pentavalent atoms such as arsenic, antimony, or phosphorus, which leave unbonded electron which is free to be excited into the conduction band and conduct electricity. Pure semiconductors such as silicon has 4 electrons in its outermost shell, which undergo covalent bond with pentavalent atom such as antimony, which has 5 electrons in its outermost shell. 4 electrons of antimony undergo covalent bond with silicon atoms. One electron is going to be unbonded, which is free to be excited into conduction band to conduct electricity. Another antimony atom is going to be bonded. 4 electrons of antimony undergo covalent bond with silicon atoms. Antimony has 5 electrons. 4 electrons have been bonded to the silicon atoms. Therefore, one unbonded atom, which is free to be excited to the conduction band to conduct electricity. Another antimony atom, which has 5 electrons in its outermost shell. 4 electrons are going to be bonded with silicon atoms. One unbonded electron, which is free, is going to be excited to conduction band to conduct electricity. Another antimony atom, 4 electrons of antimony atom are going to be bonded to the silicon atoms. One unbonded electron, which is free to be excited to the conduction band and conduct electricity. These free electrons are majority charge carriers in N-type semiconductors.